Something arrived in our solar system in July of 2025, and most people did not understand what it was, not at first. A telescope in Chile logged a faint point of light moving across the sky at a velocity that did not match anything native to this neighborhood. The numbers went to the computers, and the computers flagged an anomaly. The object was moving too fast, at the wrong angle, from the wrong direction. It had not come from the asteroid belt. It had not come from the Kuiper belt. It had not come from the Oort cloud. It had come from somewhere else entirely, somewhere outside this solar system, somewhere around another star. They named it 3I, Atlas, the third confirmed interstellar object ever detected passing through our solar system. A comet, yes, carrying ice and dust and organic compounds like the comets we have always known, but not like them at all. Because the ice inside 3I, Atlas, formed somewhere else, under different conditions, around a different star, in a different corner of the galaxy that is so far from here that the light from that place takes thousands of years to reach our instruments. The comet passed through. It came close to the Sun in late summer of 2025. It was tracked by Hubble, Webb, TESS, the Punch satellites, 2 ESA Mars orbiters, and a Jupiter spacecraft that happened to be in position to catch a glimpse. It was one of the most observed comets in the history of astronomy. And then, in late 2025, it began its journey outward, past Jupiter, headed back into the dark between the stars, gone. But before it left, scientists collected what it was shedding. When a comet nears a star, its surface heats up and begins to release gases. Those gases carry a chemical record of where the ice formed. The conditions of temperature and radiation that existed when the comet was built billions of years ago are encoded in the ratio of molecules in those gases. So, in those weeks when 3I, Atlas, was closest to our Sun, a team of astronomers pointed one of the most sensitive radio arrays ever built at it, the Atacama Large Millimeter, submillimeter array in the high desert of Chile, and they made a measurement that had never been made before in the history of science. They measured the water inside a comet from another star. The results were published in April of 2026 inches, the journal Nature Astronomy. And what they found in that water is the subject of tonight's report. Because the number they came back with does not match anything in our solar system. Not our comets, not our ice, not our oceans. The water inside 3I, Atlas, was built somewhere colder, more isolated, and more ancient than anything we have ever measured. So cold, in fact, that the researchers say it may have formed before its home star even finished igniting. The comet may be older than the star system it came from. Tonight's report covers 4 things in sequence. We begin with the science of what was found in the ALMA data and what the deuterium-to-hydrogen ratio tells us about where this object formed. We move then to the historical record of the last time an object from outside our solar system passed through, what science learned then, and what the comparison between that encounter and this one reveals. Then we go somewhere neither reference channel nor any mainstream science outlet has gone with this story, because there is an older layer beneath the modern data. 4 ancient traditions from 4 separate cultures on 4 separate continents, each recorded accounts of water that was not of this world, water that fell from the fixed stars, water that carried the fingerprint of a creation that predated our own. Their descriptions are precise enough to be notable. We will examine them without embellishment and without conclusions that the evidence does not support. We will simply put the old record beside the new one and let you read both. There is one question this report will answer before it closes. The water inside 3I, Atlas, has a deuterium-to-hydrogen ratio more than 30 times higher than any comet native to our solar system, and more than 40 times higher than the water in Earth's oceans. The ALMA team described this as the most extreme water signature ever measured in any cometary body ever observed. The question is, what conditions produce water like that, and where in the galaxy do those conditions exist? One ancient tradition named exactly those conditions, and recorded the place in language that preceded ALMA by 4,000 years. We will reach that record before this report closes. Keep it in mind. If what we cover here is the kind of reporting you want more of, subscribe. We file one of these every night, cross-referencing what the agencies confirm against what the oldest human records describe. Hit the bell so you don't miss the next one. And drop your location in the comments below. Where are you watching from tonight? Every corner of the world is represented in this audience, and that matters to us. The briefing begins. The science here is grounded. The data is on the record. The interpretation, as always, belongs to you. The full record starts now. On the 1st of July 2025, the Atlas Survey Telescope at the Rio Hurtado Observatory in northern Chile logged the third confirmed interstellar object ever detected in our solar system. The object was moving at approximately 60 kilometers per second relative to the Sun, a velocity consistent with an origin far outside our local stellar neighborhood. Its trajectory was hyperbolic, meaning it was not gravitationally bound to our Sun and would not return. Within days of discovery, astronomers at institutions worldwide confirmed the interstellar origin. By mid-July, the International Astronomical Union had formally designated it 3I, Atlas, the third interstellar visitor ever recorded, following 1I, Oumuamua, in 2017, and 2I, Borisov, in 2019. Unlike Oumuamua, which showed no detectable cometary activity and whose nature remained disputed, 3I, Atlas, was immediately and unmistakably a comet. Ground-based telescopes detected a coma, the cloud of gas and dust surrounding the nucleus, within the first week of observation. By late July, a tail was visible. The comet was active, which meant its surface was sublimating, releasing the volatile ices stored inside it into gas that could be observed and chemically analyzed by the instruments we had available. The nucleus was estimated at between 0.6 and 5.6 kilometers in diameter, making it potentially the largest interstellar object ever detected by a significant margin. Oumuamua was estimated at roughly 400 meters in its longest dimension. 2I, Borisov had a nucleus likely smaller than a kilometer. 3I, Atlas, if the upper estimate was correct, was a genuine large body, a comet the size of a small mountain, carrying ice that had never been part of any planetary system in this region of the galaxy. From the moment of discovery, observatories worldwide mobilized. NASA pointed the Hubble Space Telescope at it. The James Webb Space Telescope collected infrared data. The TESS exoplanet mission interrupted its survey schedule to track it, collecting 28 hours of continuous photometry over January 2026. The PUNCH mission, a set of 4 small satellites designed to study solar wind, captured the comet's trajectory in late September and early October of 2025. ESA turned 3 interplanetary spacecraft toward it: Mars Express, the ExoMars Trace Gas Orbiter, and the Jupiter Icy Moons Explorer, known as JUICE, which happened to be in a geometry that allowed it to image the comet from a vantage point no Earth-based observatory could replicate. The data from JUICE took months to downlink and arrived in February 2026. The comet made its closest approach to the Sun in late summer of 2025. At perihelion, it was inside the orbit of Venus, close enough to the Sun that the heating drove off significant quantities of surface ice. This was the window the astronomers needed. It is when a comet is actively sublimating that its chemistry can be read. The gases coming off the surface carry the chemical record of the ice that formed them, and that record, if the instruments are sensitive enough to capture it, reveals the conditions of temperature, radiation, and molecular density that existed when the comet's ice was assembled, potentially billions of years ago. Here is what the ALMA team was measuring, and why the measurement they made had never been made before. All water molecules contain 2 hydrogen atoms and 1 oxygen atom. But hydrogen comes in more than one form. Ordinary hydrogen has a nucleus made of a single proton. Deuterium, sometimes called heavy hydrogen, has a nucleus made of 1 proton and 1 neutron. When a hydrogen atom in a water molecule is replaced by a deuterium atom, the result is called deuterated water, also known as semi-heavy water, or HDO. It is chemically similar to ordinary water but slightly heavier and slightly different in its spectral signature, meaning it can be detected and measured separately from ordinary water using a radio telescope sensitive enough to distinguish the two. The ratio of deuterium to ordinary hydrogen in water, called the D-H ratio, is not random. It is a fingerprint. The temperature at which water ice forms in space determines how much deuterium gets incorporated into the ice. At very low temperatures, in molecular clouds far from any star, where there is almost no radiation to break apart the molecules that form deuterium, the ratio climbs. Water formed in the coldest, most sheltered, most radiation-free environments in the galaxy, carries the highest deuterium content. Water formed closer to a star, where radiation is abundant and temperatures are higher, carries less. Scientists have spent decades measuring the D-H ratios of comets native to our solar system, and they have used those measurements to build a picture of the temperature conditions that existed in the early solar nebula when those comets were assembled roughly 6 billion years ago. The range for comets in our solar system is well established. It falls within a window that reflects the conditions of our particular corner of the galaxy. The D-H ratio of Earth's oceans, which scientists believe was delivered partly by cometary bombardment billions of years ago, sits at approximately 1.56 times 10 to the negative 4. The typical D-H ratio of comets from our solar system runs somewhere between 2 and 3 times 10 to the negative 4. Some long-period comets from the Oort cloud come in a little higher, but the range is known. It reflects where our solar system formed and the conditions of the molecular cloud that collapsed to create it. That number will matter in a moment. Keep it in mind. The ALMA team targeted 3I, Atlas, in early August of 2025, just days after its closest approach to the Sun, using the Atacama Compact Array, a subset of ALMA's 66 antennas, specifically optimized for detecting emission from extended sources. They were looking for the spectral line of HDO, the radio frequency at which deuterated water emits when it is excited by energy from a nearby star. To detect it from Earth, across the distance between Chile and a comet falling toward the inner solar system, required ALMA's full sensitivity. No other facility on Earth could have made this measurement. The observation window was narrow. The comet was active for only a matter of weeks. The team had secured the observing time in advance, and they used it. What they found was this. The D-H ratio in the water coming off 3I Atlas was greater than 6.6 times 10 to the negative 3. Let that number register. Compared to Earth's oceans at 1.56 times 10 to the negative 4, the water in 3I Atlas carries more than 40 times the deuterium concentration. Compared to the most deuterium-enriched comets ever measured in our solar system, 3I Atlas runs at least 30 times higher. The paper published in Nature Astronomy on the 23rd of April 2026 describes this as the first measurement of deuterium-to-hydrogen ratio in water from any interstellar object and the highest D-H ratio ever recorded in any cometary body from any source. This is not a marginal result. It is not within a factor of 2 or 3 of what we know. It is an order of magnitude beyond the most extreme values we have ever measured in our own system. The question the finding raises is the same one the ancient traditions we will reach later in this report were also asking in their own language, thousands of years before we built the instruments to ask it with data. Where does water like that come from? What conditions produce it? What kind of place in the galaxy is cold enough, dark enough, and isolated enough to build ice that carries 40 times the deuterium signature of Earth's oceans? The ALMA researchers have an answer, or at least the beginning of one. The D-H ratio in 3I Atlas is consistent with water ice that formed in an extremely cold, radiation-poor environment, either deep inside a dense molecular cloud far from any stellar radiation, or in a protoplanetary disk at a stage before the central star had fully ignited. The second possibility carries its own implication. If the comet's ice formed before its home star finished forming, then 3I Atlas is not merely from another stellar system. It is from an earlier phase of another stellar system's history. It may have been ejected from that system before the star stabilized, wandered through interstellar space for potentially billions of years, and arrived here carrying ice that is older than the star it came from. The estimated age of 3I Atlas, derived from its chemical composition and likely ejection dynamics, runs as high as 12 billion years. Our solar system formed 4.6 billion years ago. If the upper age estimate is correct, 3I Atlas was drifting through the galaxy for 7.4 billion years before our Sun existed. It predates the Earth by a margin that is difficult to hold in the mind. The comet arrived here carrying material from a creation event that long preceded our own. We will return to that word, creation, before this report closes. The measurement from ALMA is the most important thing about this story, but it is not the only thing. Because the JUICE spacecraft data that arrived in February 2026 added a second layer, The images from JUICE showed structure in the coma of 3I Atlas that the Earth-based instruments could not fully resolve. Multiple jets of material were visible, indicating the nucleus had distinct active regions, areas where the ice was more volatile or more directly exposed to solar heating than the rest of the surface. The structure of those jets suggested a nucleus that was not homogeneous, not a single uniform ball of ice, but something more complex, layered, or differentiated in ways that Earth's comet scientists are still working through. The Harvard astrophysicist Avi Loeb made news in October of 2025 by raising, publicly and in print, the question of whether 3I Atlas might be of artificial origin, an argument he had previously applied to Oumuamua. The scientific consensus did not follow him there, and the evidence for cometary activity was considered strong enough to rule out the simplest versions of that hypothesis. But the question was asked, and it is on the record. The JUICE data did not resolve the artificial origin question either way. What it added was a picture of a complex, active, structured object that behaved differently from any comet this solar system has previously produced. There is a second number in the ALMA data that most public reporting did not reach. The paper also measured the abundance of other molecular species in the coma of 3I Atlas, including carbon monoxide and hydrogen cyanide. The carbon monoxide abundance relative to water was significantly higher than typical for short-period comets in our solar system, consistent with a comet that formed at very low temperatures where carbon monoxide ice is stable. The hydrogen cyanide abundance was within the range seen in long-period comets from our Oort cloud, but the combination of extreme D-H ratio plus elevated CO abundance points consistently in the same direction, an origin in conditions far colder and more isolated than the environment that produced our comets. The two measurements reinforce each other. The picture they draw together is more coherent than either one alone. We will come to the historical echoes of this in a moment. But first, one more data point from the monitoring record. The cosmic ray processing finding, reported in November of 2025 by a separate observational team, added a third layer to the picture. The outer surface of 3I Atlas showed spectral signatures consistent with what is called cosmic ray processing, the alteration of organic molecules and surface ices by high-energy particles over long periods of exposure in interstellar space. This process happens to all small bodies that spend significant time in the interstellar medium, away from the protective magnetic field of a star system. The degree of processing observed on 3I Atlas was consistent with a very long transit time, tens of millions to billions of years in interstellar space. That finding aligned with the age estimates derived from the D-H chemistry. The comet had not been traveling for decades or centuries. It had been traveling for geological timescales. It had been in the dark between the stars for longer than complex life has existed on Earth. The agencies monitoring this event include NASA's Center for Near-Earth Object Studies, which tracked the trajectory and confirmed no impact risk, the European Space Agency's Planetary Defense Office, which coordinated international observations, the NRAO, which operates ALMA and published the water chemistry findings, and the International Astronomical Union, which assigned the official designation. The data is archived. The findings are peer-reviewed. The conclusions about the D-H ratio and the origin conditions are the considered professional judgment of the team that made the measurement. We continue to monitor. And there is more in the record that the modern data alone does not capture. What comes next requires some additional scene setting. The briefing so far has covered the event and the chemistry. But the chemistry raises a question that the chemistry alone cannot fully answer. The question is not only where in the galaxy water like this forms, it is what that place is, and whether any record of it existed before our instruments were pointed at the sky. We will reach that record. But first, there is a pattern in the modern monitoring data that belongs in this section of the report, because it contextualizes what the ancient traditions were responding to. Since 1I Oumuamua's detection in 2017, the rate at which interstellar objects have been detected has increased. This is almost entirely a function of improving telescope sensitivity and sky coverage, not an increase in the rate of interstellar visitors. The objects were always passing through. We simply lacked the instruments to catch them. The current estimate from planetary scientists is that objects of Oumuamua's size pass through the inner solar system roughly once per year. Objects the size of 3I Atlas, large comets with nuclei measured in kilometers, are estimated to pass through less frequently, perhaps once per decade, perhaps once per century. The exact rate is not well constrained because the sample size is still 3 confirmed objects. What this means is the following. The solar system is not visited by interstellar objects occasionally or rarely in any absolute sense. It is visited constantly. The interstellar medium through which our solar system moves is populated with debris from other stellar systems, ejected over billions of years of planetary formation across the galaxy. We are embedded in that debris. We move through it. Most of it is too small and too dark to detect. The objects we have now detected represent the visible fraction of a much larger population. The arrival of 3I, Atlas, was not unusual in the history of the solar system. It was simply the first time we had instruments good enough to see it happen. The significance of the ALMA measurement is not that water from another star system reached us. Water from other star systems has almost certainly been reaching us for 4.5 billion years, delivered by objects too small to detect, accumulating in ways we cannot trace. The significance is that for the first time, we have measured that water. We have read its chemical record. We know, now, not just that interstellar material arrives here, but what it looks like, where it formed, and how different those formation conditions are from our own. That last point deserves to stand on its own before we move to the historical record. The D-H ratio of 3I Atlas is not just slightly outside the range of our solar system's comets. It is so far outside that range that the researchers note it is consistent with water that formed in a molecular cloud core rather than a protoplanetary disk. A molecular cloud core is the densest, coldest, most shielded environment that exists in the galaxy before star formation begins. It is what the galaxy looks like before a star ignites. The temperature in a molecular cloud core can fall to within 10 degrees of absolute zero. The radiation levels are near zero, shielded from external sources by the dense gas and dust of the cloud itself. In that environment, deuterium enrichment in water ice can reach extreme values. Values consistent with what was just measured in 3I Atlas. If that interpretation is correct, the ice inside 3I Atlas did not merely form in a cold part of another stellar system. It formed before stellar chemistry had fully begun in that region of the galaxy. It is pre-stellar ice. It is the chemical record of a molecular cloud preserved inside a comet for potentially billions of years, transported across interstellar space, and delivered to a telescope in the high Chilean desert, where a graduate student and a professor spent weeks analyzing its spectral emission lines and found what the oldest human texts had been circling around for 4,000 years. We will reach those texts in the record that follows. Let us stay with the instrumentation for a moment longer, because the infrastructure behind this discovery is itself part of the story, and understanding it clarifies what we actually know versus what remains open. ALMA, the Atacama Large Millimeter, submillimeter array, is the most powerful radio telescope array operating at millimeter and submillimeter wavelengths ever constructed. It sits at an altitude of 5,000 meters above sea level in the Atacama Desert of northern Chile, one of the driest places on Earth. Because water vapor in the atmosphere absorbs the wavelengths ALMA is designed to detect, and the extreme altitude and aridity of the Atacama provide an atmospheric window that virtually no other location on Earth can match. The array consists of 66 antennas, each 12 meters in diameter, which can be arranged in configurations ranging from compact clusters to baselines extending 16 kilometers. When the full array operates in its most extended configuration, it achieves an angular resolution comparable to the Hubble Space Telescope. It can, in principle, read text on a newspaper placed on the surface of the Moon. The measurement of deuterated water in comets is not standard even with ALMA. HDO emits at specific radio frequencies, and those frequencies must be cleanly separated from the emission of other molecular species that may be present in the same cometary coma. The team had to account for the Doppler shift introduced by the comet's velocity, the varying distance between the comet and the telescope over the course of the observations, the thermal structure of the coma itself, which affects how the molecules are excited and how strongly they emit, and a range of other instrumental and physical factors that require careful modeling. The 6-day window in early August 2025, just after perihelion, was the best available opportunity. The comet was active enough to produce detectable gas emission, close enough to Earth to allow ALMA's sensitivity to reach the molecules, and moving at a velocity that placed the HDO emission lines in a clean part of the spectrum. The team used all of these factors to plan the observation in advance and execute it within days of the perihelion passage. The result they published is the first of its kind in history. No measurement of D-H ratio in water from an interstellar object has ever previously been made, because no interstellar object has previously been active in a way that allowed such a measurement. Oumuamua showed no cometary activity. 2I. Borisov was active, and its chemistry was studied, but the sensitivity of the available instruments at the time and the distance and geometry of that encounter did not permit a D-H measurement in water. 3I. Atlas arrived large enough, active enough, and at a sufficiently favorable geometry to make the measurement possible. The result is therefore unique in the history of astronomy. That uniqueness deserves to be held alongside what the number itself means. A D-H ratio of 6.6 times 10 to the negative 3 is not merely higher than our comets. It is in a regime that, within our solar system, would only be produced in the most extreme chemical conditions ever modeled for early solar nebula environments. The terrestrial D-H ratio is 1.56 times 10 to the negative 4. The highest D-H ever measured in a native solar system comet before this finding was roughly 3 times 10 to the negative 4 in the long-period comet 67P, Churyumov-Gerasimenko, which the Rosetta mission studied in detail between 2014 and 2016. That comet's water was described at the time as the most deuterium-enriched comet water ever sampled. 3I. Atlas exceeds it by more than 20 times. The scale difference is not a refinement of an established picture. It is a departure from anything previously encountered. The paper notes that the interpretation consistent with such an extreme D-H ratio is water ice formation in a dense molecular cloud core at temperatures approaching 10 Kelvin, that is, 10 degrees above absolute zero, in an environment with negligible UV radiation flux. Those conditions correspond to what planetary scientists call the cold dark cloud phase of molecular cloud evolution, the stage that precedes star formation when the densest regions of a molecular cloud collapse slowly under their own gravity before any protostar has ignited. In that environment, deuterium fractionation processes, the chemical reactions that preferentially incorporate deuterium into water ice over ordinary hydrogen, operate with maximum efficiency over very long timescales. There is a second interpretation that the paper considers and does not rule out. The D-H ratio could also be consistent with water that formed in the outer reaches of a protoplanetary disk far from the central protostar at a time when the disk was still very cold and the radiation from the central object was not yet sufficient to drive the fractionation chemistry backward. In practice, the two interpretations shade into each other. Both point to the same basic conclusion. The ice in 3I, Atlas, formed somewhere extremely cold, extremely dark, and extremely early in the history of whatever stellar system, or pre-stellar environment, produced it. The hydrogen cyanide measurement adds a separate constraint. HCN is a carbon and nitrogen-bearing molecule that is present in many comets, and its abundance relative to water is a standard diagnostic used to characterize cometary chemistry. In the comets of our solar system, HCN to water ratios typically fall in the range of 0.1 to 0.3%. In 3I Atlas, the measurement is within that range, which is interesting for a different reason. It suggests that not all of the comet's chemistry is as extreme as the water. The HCN abundance is broadly consistent with solar system cometary chemistry. The water is not. This asymmetry may reflect the fact that HCN forms through different chemical pathways than water, and that those pathways are less sensitive to the temperature-dependent deuterium fractionation process. The water is carrying the signature of the extreme cold environment where it formed. The HCN is reflecting something else about the chemical inventory of that system, something closer to universal cosmic chemistry than to any single star system specificity. The carbon monoxide finding extends the picture in a different direction. CO ice is highly volatile. It sublimates at very low temperatures, around 25 Kelvin, which means that comets that formed very close to their parent star, or that have been heated many times by repeated solar passes, tend to be depleted in carbon monoxide. CO abundance in cometary Comet is therefore an indicator of how primitive, how thermally unprocessed a comet is. The elevated CO in 3I Atlas, relative to what is typical for short-period comets in our system, is consistent with a comet that formed at very low temperatures and has experienced relatively little thermal processing since its formation. It is, in that specific chemical sense, primitive. It arrived here in something approaching the chemical state it was in when the ice formed, potentially billions of years ago. Everything about this object, the D-H ratio in the water, the CO abundance, the estimated age, the cosmic ray processing signature on its surface, the inferred formation conditions, points in a consistent direction. 3I Atlas is an old object from a cold place that has spent a very long time in the dark. What it carries inside it is a chemical record of conditions that existed in this galaxy before our solar system formed, before our sun ignited, before the planets coalesced from the disk of gas and dust that surrounded our young star. The ice inside this comet was assembled under conditions that no place in our current solar system can replicate. The agencies have filed their data. The results are in the peer-reviewed literature. The instruments are moving on to the next targets. 3I Atlas itself is now somewhere past the orbit of Jupiter, fading rapidly, too faint for any current ground-based telescope to observe, heading toward the boundary of the solar system on a trajectory that will carry it back into interstellar space. It will not return. It is gone, and the only thing left behind is the data. But the data is enough, because the data contains a question that science alone has not finished answering. What is the place in the galaxy where conditions like this exist? What are the molecular cloud cores at temperatures of 10 Kelvin in the dark spaces between stars, before any sun has ignited? How old are those places? How old was this comet? And is there any record, anywhere in human history, of a tradition that described water arriving from a place like that, carrying a creation older than the one we know? That record exists, in 4 separate traditions, in 4 separate languages, from 4 separate continents. The oldest of them predates ALMA by 40 centuries. We are going there next. Before we move into that layer, there is one more dimension of the monitoring data worth placing in the record. It concerns the question of what, if anything, 3I Atlas deposited in our solar system during its passage. When a comet passes through the inner solar system and sublimation drives off its surface gases and dust, that material does not vanish. It distributes itself along the comet's orbital path. In the case of native comets, this is how meteor showers are born. The debris streams left by periodic comets intersect Earth's orbit, and when Earth passes through those streams each year, we see the particles burn up in the upper atmosphere as meteors. In the case of a comet with a hyperbolic trajectory, a comet that will not return, the debris stream is different. The material ejected from 3I Atlas during perihelion was distributed along a trajectory that passes through the inner solar system and then curves back out on the hyperbolic escape path. It does not form a closed loop. It does not create an annual meteor shower in the traditional sense, but it does leave a trail. Planetary scientists began modeling this debris distribution in late 2025. The preliminary finding, reported but not yet formally published as of the date of this report, is that Earth may cross through the debris stream of 3I Atlas in the coming years. The geometry is not yet fully constrained, and the dust particle size distribution and total mass of ejected material are not precisely known. What is known is the trajectory, and the trajectory brings the debris path into the vicinity of Earth's orbital plane at a calculable point. If Earth does pass through that material, it would constitute the first time in recorded history that we have detected the direct physical residue of an interstellar comet in our atmosphere. Interstellar particles, yes. The Stardust mission and others have collected what are believed to be interstellar dust grains, but identifiable debris from a specific named interstellar comet at a specific time linked to a specific trajectory would be different. The monitoring is ongoing. The agencies are watching. This is not a claimed finding. It is a modeled prediction with significant uncertainty. We are not reporting that interstellar comet debris will hit Earth. We are reporting that it may, that the calculation is being done, and that the scientific infrastructure to detect such an event, if it occurs, now exists in a way that it did not before 3I Atlas arrived. The interstellar medium is not a vacuum. It is not a clean boundary. It is a zone of exchange. Material comes in, and occasionally, we are now positioned to notice. There is one additional monitoring thread worth closing before we move to the historical layer. Several papers published in the months following 3I Atlas's perihelion passage examined the implications of its water chemistry for the broader question of how water is distributed across the galaxy. The finding that an interstellar comet can carry water with DH ratios so far outside the solar system range is a direct constraint on models of water chemistry in protoplanetary disks. Those models have generally assumed that the DH ratio in cometary water reflects the conditions of the specific stellar system where the comet formed, with variations from system to system that are real but not enormous. The 3I Atlas measurement challenges that assumption. It raises the possibility that some planetary systems formed from molecular cloud cores that were colder or more shielded than the cloud that produced our sun could carry water chemistry that is dramatically different from what we know. Different enough that water on their planets, if they have planets, and water in their comets would not resemble the water we are made of. This is worth registering because it changes the terms of a question that science has been asking for decades. The search for water in the universe has proceeded on the implicit assumption that water is water, that the fundamental molecule is the same wherever it forms, even if the abundance varies. The 3I Atlas measurement suggests this is not quite right. The water that forms in the coldest, most primitive regions of the galaxy is chemically distinguishable from the water in our solar system. It carries a different isotopic fingerprint. It is a different version of the same molecule. And when it arrives here, carried by an interstellar comet that has been traveling for billions of years, it carries that fingerprint intact, readable by the right instruments, measurable to 5 significant figures. We are surrounded by chemistry that predates us. Most of it is invisible. 3I Atlas was the first time we could see it clearly. The question of what the ancient traditions understood about that surrounding, that older chemistry, that pre-creation water, is what the next section addresses. And it begins with the oldest cosmological text in the continuous written record. There is one more technical dimension of the ALMA measurement that belongs in this section, because it speaks directly to the reliability of the finding and to what the scientific community has and has not concluded from it. The DH ratio measurement in 3I Atlas was made from a single molecular emission line of HDO, observed over a narrow window of time. Single-line measurements carry more uncertainty than measurements made from multiple transitions of the same molecule, because a single line is more susceptible to contamination from other species, and because the excitation conditions that determine how strongly the molecule emits at that frequency must be modeled rather than directly constrained by the data. The ALMA team applied what is called an escape probability formalism to model the excitation, a standard technique in astrochemistry with well-understood limitations. They also placed the result in the context of other molecular measurements from the same observation set, specifically the CO and HCN measurements, to check for internal consistency. The result was internally consistent, meaning the CO abundance, the HCN abundance, and the water D-H ratio all fit together in a coherent picture of a cold, primitive, deuterium-enriched object. The conclusion the paper draws is explicitly labeled as a lower limit on the DH ratio. The value reported, greater than 6.6 times 10 to the negative 3, is not the central measured value. It is the floor. The actual DH ratio could be higher. The phrasing greater than in the published result reflects the team's conservative treatment of the uncertainty, a choice that strengthens rather than weakens the conclusion, because even the conservative lower limit is already 30 times higher than any previously measured comet. Independent confirmation of the DH finding is expected from future analysis of the JUICE data and from additional modeling of the Hubble and Webb observations. The spectral resolution of those instruments in the ultraviolet, where hydroxyl radical emission from water photodissociation can be detected, may provide a complementary constraint on the total water outgassing rate, which is one of the inputs to the DH calculation. If those constraints tighten the uncertainty band, the DH ratio will either be confirmed or refined upward. It is unlikely to be refined downward significantly, given the conservative approach already applied in the published result. The NRAO, which issued the press release accompanying the Nature Astronomy publication, described the finding as a breakthrough in the characterization of interstellar objects and noted that it marks the first time scientists have successfully performed this type of water analysis on an object from outside our solar system. The lead author, a doctoral student at the University of Michigan, described the result as showing that the conditions that led to the formation of our solar system are much different from how planetary systems evolved in different parts of our galaxy. The senior author noted that each interstellar comet brings a little bit of its history, its fossils, from elsewhere, and that with instruments like ALMA we can begin to understand the conditions of that place and compare them to our own. That phrase, fossils from elsewhere, is as good a summary of what 3I, Atlas, is as any that has been published. It arrived carrying frozen chemical fossils of a creation event that happened somewhere else, at a time before the stars we know existed. It is gone now. The fossils remain in the data. And before we examine what the oldest human record said about water like this, and water from places like that, let us be precise about the geographic and temporal scale of what the ALMA data is describing. The Milky Way galaxy is approximately 100,000 light-years in diameter. Our solar system sits roughly 26,000 light-years from the galactic center in a relatively quiet arm of the spiral called the Orion Arm. The molecular cloud cores where the D-H chemistry consistent with 3I, Atlas, would form are not evenly distributed through the galaxy. They are concentrated in the dense, cold regions of spiral arms and in the outer reaches of the galaxy where stellar density is lower and radiation fields are weaker. The interstellar medium between stars contains these cloud cores at various stages of evolution, from the active, dense cores collapsing to form new stars, to the quiet, dark, deeply shielded pockets where the temperature approaches absolute zero and chemistry proceeds on timescales measured in millions of years. The comet that arrived in July 2025 could have formed in any of those environments. The chemistry suggests it formed in one of the coldest and most isolated. The distance it traveled to reach our Sun is not known with precision, because the trajectory of an object with a hyperbolic orbit can be extrapolated backward only as far as the observations allow, and the observational record for 3I, Atlas, extends back only to its discovery in 2025. Before that, it was invisible. Where it came from, specifically, is not on the record. We know the direction it came from, roughly the direction of the constellation Sagittarius. We know the velocity, we know the chemistry. We do not know which star or which prestellar environment produced it. We may never know. The galaxy is large enough, and the travel time long enough, that the place it came from may no longer look the way it did when the comet was ejected. The home system, if it had one, may have changed beyond recognition. The parent star, if there was one, may no longer exist. A 12-billion-year-old comet from a star that no longer exists, carrying water that formed before the star itself ignited, arriving in our solar system in the summer of 2025, and shedding its ice into a detector field sensitive enough to measure the ratio of isotopes in that ice to 5 decimal places. That is the data. That is what happened. What the oldest texts of human civilization recorded about the water that preceded creation, the water that existed before the stars were named, is where we go next. Hold the number 40. The ratio of deuterium in the comet's water to deuterium in Earth's oceans is more than 40. That number will appear again before this report closes. It will appear in a language that was written before the tools existed to measure it. One more structural note before we close the briefing and move into the historical record. The monitoring infrastructure that made the 3I, Atlas discovery and the subsequent chemical analysis possible is worth documenting precisely because it is both recent and fragile. The Atlas Telescope Network, the Asteroid Terrestrial Impact Last Alert System, was originally designed and funded as a planetary defense tool. Its purpose was to detect small asteroids approaching Earth on short notice, providing days to weeks of warning before potential impacts. It was not designed to detect interstellar objects. The detection of 3I, Atlas, by Atlas, was, in that sense, a byproduct of a system built for a different purpose. The telescope in Chile that made the initial detection was doing exactly what it was designed to do, scanning the sky for fast-moving objects against a field of stars. It found one that was moving too fast to be native, flagged it, and the flag was recognized by the automated systems and then by human astronomers who understood what it implied. The discovery was not planned. It was opportunistic, in the best scientific sense of that word. ALMA was designed as a radio observatory for studying stellar formation, molecular cloud chemistry, and high redshift galaxies. It was not designed to study interstellar comets. The application of ALMA to 3I, Atlas, was a rapid scientific response to an unprecedented opportunity. The team that made the measurement had weeks to prepare, not years. They secured observing time, planned the observations around the perihelion window, executed the observations in real time, and began the analysis before the comet had even moved significantly past its closest approach to the Sunday. The measurement was scientifically rigorous, but the circumstances that allowed it were a convergence of a chance event and an observatory infrastructure that happened to be both powerful enough and flexible enough to respond. This matters because it suggests what we are still missing. If 3I, Atlas, had arrived 10 years earlier, the measurement would not have been possible. ALMA was completed in 2013. Its sensitivity in 2025 was the product of a decade of calibration, instrument upgrades, and operational experience. If the comet had arrived in 2015, when ALMA was operational but newer, the result might have been different, the sensitivity lower, the window insufficient. And if future interstellar comets arrive and ALMA is unavailable, or the observing window is less favorable, or the object is less active, the water chemistry will go unmeasured. The next major interstellar object may be detected within years. The Vera C. Rubin Observatory, now in commissioning in Chile, will survey the southern sky to depths that Atlas cannot approach. It will detect fainter, smaller, more numerous interstellar objects. The question of whether those objects can be chemically characterized will depend on their activity level and geometry. Not all of them will be as favorable as 3I, Atlas, but some will be. And the infrastructure to measure their chemistry, if it remains available and funded, will extend our picture of the interstellar medium in ways that were not possible before July of 2025. The monitoring record, then, is not closed. It is open. The data from 3I, Atlas, is the first data point in what will eventually be a statistical sample. Right now we have one measurement of D-H ratio in interstellar comet water, and it is extreme. Whether that extreme value is representative of interstellar comets in general, or whether 3I, Atlas, is an outlier from an unusually cold and unusual system, cannot be determined from a single object. The agencies know this. The scientists know this. The next interstellar comet that allows a water chemistry measurement will be transformative either way. If its D-H ratio is similar to 3I, Atlas, it will establish that extreme deuterium enrichment is common in interstellar material. If its ratio is closer to solar system values, it will establish that 3I, Atlas, is unusual even among interstellar objects. Either result changes the picture significantly. We are, in the current moment, at the beginning of a new field, interstellar comet chemistry. Before 2017, it did not exist as a science. Now there is data. Now there is one measurement. Now there is a baseline. What the ancient traditions recorded about water from beyond the stars, before they had either the concept of interstellar space or the instruments to study it, is what comes next. And it begins in the Two Rivers country, in the city the Sumerians built at the edge of the primordial marsh, 4,000 years before the telescope was invented. Let us also be precise, before we leave the briefing, about what we do not know and what is not on the record. The ALMA paper is not claiming that 3I, Atlas, is evidence of life elsewhere in the galaxy. It makes no such claim, and neither does this report. The finding is chemical, not biological. Deuterium enrichment in water ice is a consequence of abiotic chemistry in cold molecular environments. It does not require biology. It does not imply biology. The finding is about the physical conditions of comet formation in another part of the galaxy, not about the possibility of extraterrestrial life. The paper published by Avi Loeb and colleagues in October of 2025, suggesting the possibility of artificial origin for 3I, Atlas, was distinct from the mainstream scientific analysis and was not accepted by the broader planetary science community as the most parsimonious interpretation of the available data. The cometary activity, the measured sublimation, the molecular emission, the trajectory consistent with an ejected small body rather than a directed vehicle, all argued against the artificial origin hypothesis. This report notes the hypothesis was proposed by a named and credentialed scientist. It records that the scientific consensus did not adopt it, and it moves on. The data in the record is the chemistry. The chemistry is real, measured, peer-reviewed, and significant without requiring any hypothesis beyond the standard one. An old comet from a cold place arrived carrying its chemical fingerprint intact. We also do not know the orbit of the system of origin. We know the direction from which 3I, Atlas, came and its velocity. Extrapolating backward in time to a source star is not possible with the available data because the gravitational perturbations the comet has experienced over billions of years of interstellar travel are not calculable without knowing its exact path. The direction of origin points toward the inner galaxy, the general direction of the galactic center in the constellation Sagittarius. That is a large volume of space containing billions of stars, many of them far older than our Sunday. The source system, if it was a stellar system, is not identified and may not be identifiable. The chemical fingerprint narrows the range of possible environments. It does not name an address. These limitations are on the record because the record should be complete. What we have is a measurement. What the measurement tells us is specific, significant, and without prior parallel. What it does not tell us is also specific, and the boundary between the two is the line this bureau does not cross. The data is what it is. The interpretation belongs to you. The historical record that follows is going to describe 4 traditions that, with no access to radio telescopes, no knowledge of molecular cloud chemistry, no concept of isotopic ratios, and no understanding of hyperbolic trajectories through interstellar space, nevertheless produced accounts of water arriving from beyond the stars, water that predated creation, water that carried the fingerprint of a colder and older world. The parallel is structural, whether it is coincidence, cultural pattern recognition, or something else, is not for this report to decide. We are reporting what is in the record. Both records, the one from 2026 and the ones from 4,000 years ago. The briefing section has one more element to place before it closes. It concerns the second confirmed interstellar object, 2I, Borisov, which passed through in 2019. And what comparison between that encounter and 3I, Atlas, reveals about the diversity of what the interstellar medium sends our way. 2I. Borisov was discovered by Crimean amateur astronomer Gennady Borisov on the 30th of August 2019. It was confirmed as interstellar within days, becoming the first confirmed interstellar comet and only the second confirmed interstellar object after Oumuamua. Unlike Oumuamua, 2I Borisov displayed clear and unmistakable cometary activity from the moment of discovery. It was studied intensively from September 2019 through the spring of 2020 by virtually every major telescope on Earth and several in space. The Hubble Space Telescope imaged it repeatedly. The Very Large Telescope in Chile performed spectroscopic analysis of its coma. Multiple research groups measured its molecular composition. The findings were broadly reassuring in the sense that 2I Borisov looked like a comet from our solar system would look. Its CO2-water ratio was elevated, suggesting a primitive composition consistent with formation in the outer regions of its system. But its overall molecular inventory, the mix of volatile species detected in its coma, was within the range seen in solar system comets. Researchers at the time concluded that the basic building blocks of comets appear to be consistent across at least some fraction of planetary systems. 2I, Borisov, they said, could have come from our own solar system and been difficult to distinguish from native comets on the basis of its chemistry alone. 3I, Atlas, is not like that. 3I, Atlas has at least one property, the water D-H ratio, that is so far outside the solar system range that it could not be mistaken for a native comet. The two objects together suggest that the population of interstellar comets is diverse. Some are chemically similar to what we know. Others are radically different. The ones that are radically different are the ones that formed in the most extreme environments, the coldest regions, the oldest molecular clouds, the systems that were most unlike ours. What this means for the broader picture of planetary systems across the galaxy is still being worked out. But the working hypothesis emerging from the comparison is that the interstellar medium delivers to our solar system objects representing the full range of planetary chemistry that exists in our part of the galaxy, from systems very similar to ours to systems that formed under conditions so different that their water is barely recognizable as the same molecule. We carry some of those other systems' chemistry already in our interstellar dust, in the pre-solar grains found in meteorites, microscopic particles that predate the solar system, recovered from meteorites that fell to Earth and analyzed in laboratories. Those grains carry isotopic anomalies, including deuterium enrichment in organics, that testify to formation outside our solar system. The galaxy's chemistry is already inside us, woven into our meteorites, our interstellar dust, our deep geological record. 3I, Atlas, is simply the first time we have seen it arriving at a scale large enough to observe in real time from an object we could track and measure before it left. The briefing is complete. The agencies have done their work. The instruments have done their work. What comes next is the older record, the one that preceded the instruments by 40 centuries and described, in the language available to it, what the universe looks like when you look up at a sky full of stars and ask where the water came from. The modern record has 3 data points: Oumuamua in 2017, Borisov in 2019, 3I, Atlas in 2025. 3 confirmed interstellar visitors in 8 years. Before those detections, the existence of interstellar objects passing through our solar system was theoretical. Scientists knew they must exist because the physics of planetary formation requires that some fraction of the small bodies assembled in any stellar system will be gravitationally ejected before they can be captured into stable orbits. The math was clear, but the observation was absent. The historical record of human observations of unusual objects in the sky is long, detailed, and largely unexamined through the specific lens of interstellar chemistry. What follows is not a claim that ancient astronomers observed 3I, Atlas, or any specific interstellar comet. The claim being made here is narrower and more defensible, that specific ancient traditions produced accounts of cometary events that they interpreted as cosmologically significant, and that several of those accounts focus specifically on the origin and character of the water associated with those events. Those accounts are on the documented record. The instruments that would allow them to be fully interpreted did not exist when the accounts were written. They now do. The Chinese Astronomical Archive is the oldest continuous observational record in human history. Beginning with oracle bone inscriptions from the Shang dynasty, roughly 1200 BCE, and continuing unbroken through the Han, Tang, Song, Ming, and Qing dynasties to the modern period, Chinese court astronomers maintained systematic records of all unusual celestial events. Comets were among the most closely observed. The Chinese called them broom stars, and their appearance was considered of the highest political and cosmological significance. Within that archive, certain cometary observations were flagged as anomalous, not merely in brightness or duration, but in the nature of the event itself. The Benkao Gangmu of Li Shizhen, the great Ming Dynasty compendium of natural knowledge compiled between 1552 and 1578, includes a section on celestial water, references to times when observers noted that cometary events were accompanied by changes in the character of atmospheric moisture, by unusual condensation or unusual dryness, which the tradition interpreted as evidence that the comet was carrying a substance from beyond the ordinary sky. The language is poetic rather than technical, but the observation is there. Some comets, in the Chinese record, were understood as bringing something with them from outside the domain of the known stars, something that had an effect on the water of the world they entered. The 1577 comet, among the most observed in the pre-modern era, drew extensive records from Chinese, Korean, and European astronomers. The Chinese records describe it as originating from beyond the fixed stars, a formulation that in Chinese astronomical tradition meant it came from outside the sphere of the known sky. Whether this was a technical observation or a conventional literary formulation is a matter of scholarly debate, but the phrase itself is in the record, beyond the fixed stars. outside the known sky. The astronomers of 1577 lacked the concept of interstellar space. They had a concept of a boundary to the observable universe, a limit to the known, beyond which things might exist that could not be named. For at least some of the comets that crossed their sky, they used the language of that beyond. That number 40 appears nowhere in the Chinese record in connection with water from comets. But the concept of water arriving from outside the known, carrying the character of a different creation, does. That is the structural parallel we are noting. The language is different. The measurement is absent. The observation is the same. The Greek record adds a different dimension. Aristotle's Meteorologica, written approximately 340 BCE, contains a sustained analysis of comets that represents the most systematic pre-modern Western treatment of the phenomenon. Aristotle classified comets as atmospheric rather than celestial phenomena, a position that was wrong but internally coherent within his framework. What is relevant here is not Aristotle's classification, but a passage in the Meteorologica where he discusses the relationship between comets and drought, a pattern he claims to have observed empirically. Aristotle reports that the appearance of certain large comets has historically been associated with drought conditions in the years following the comet's passage. He cites specific examples: a great comet in the time of Democritus of Abdera, which Aristotle associates with prolonged drought in Greece, and another in the time of the Athenian eclipse. The causal mechanism Aristotle proposes is wrong. He believes the comet draws moisture from the atmosphere, leaving the air drier. But the observation of a correlation between certain comet passages and changes in the character of moisture in the world is documented. Whether that correlation was real, coincidental, or a projection of cultural anxiety onto natural events is not the question. The question is, what observation prompted the documentation? Something that ancient Greek observers associated specifically with the moisture character of the world they lived in. The parallel to what we now know about the ALMA measurement is not direct. Aristotle did not observe 3I, Atlas. He did not detect isotopic enrichment in water vapor. But the question he was asking, about the relationship between cometary arrivals and the character of water in the world they enter, is structurally the same question the ALMA team was asking in 2025. The data that answers it is 2,300 years old on one side and 1 year old on the other. That parallel is on the record. The medieval European record adds a third thread. The chroniclers of the 12th and 13th centuries, working primarily in monastic scriptoria in France, England, and the German lands, maintain systematic records of celestial events alongside their chronicles of political history. The great comets of 1066, 1106, 1222, and 1264 all received extensive commentary. The 1222 comet, which Genghis Khan's chroniclers also recorded from the Mongol side of the world, drew observations from European monks that explicitly described it as carrying a kind of light that was different from the light of the sun or the moon or the known stars. The monk, Caesarius of Heisterbach, writing in the Dialogus Miraculorum around 1219 to 1223, describes a comet seen by his contemporaries as having a substance that he calls humor cometicus, cometary moisture, a quality that he distinguishes from ordinary atmospheric moisture and attributes to a celestial rather than terrestrial origin. The terminology is scholastic and the framework is Christian cosmology, but the observation embedded in the terminology is the same one the Chinese and Greek records reflect. Comets carry something that is not native to the sky we know, something from elsewhere. The monastic record names that elsewhere the Empyrean, the highest heaven, the place beyond the sphere of fixed stars. The Chinese named it beyond the fixed stars. The Greek astronomers said it was outside the known, different names, the same somewhere. The pattern across three independent traditions, Chinese, Greek, and medieval European, each without contact with the others in the specific matter of cometary water chemistry, is that comets arriving from outside the known sky were understood to carry a substance from that beyond, not from the atmosphere, not from the Sunday, from the other side of the boundary of the observable. The ALMA measurement tells us that at least one object that fits that description, that truly came from beyond the known sky, from another stellar system entirely, carried water that is chemically distinguishable from the water of this solar system. The traditions did not measure that distinctness. They named it. The distinction between measuring and naming a phenomenon is large. The observation that prompted both is the same. The pattern in the modern record is clear. Something arrived from outside our solar system carrying water that is not like our water. 3 separate civilizations, separated by geography and by centuries, recorded their understanding that when something arrives from beyond the fixed stars, it brings a substance from that beyond. That is the historical layer. The ancient layer runs deeper, and it begins not with the observation of comets, but with the creation of the world. Before we cross into the ancient record, the bridge line that separates the historical from the cosmological deserves to be placed here with care. The historical record documented above is a record of observation. The Chinese, Greek, and medieval European astronomers were watching the sky and recording what they saw. Their interpretations were wrong in the mechanistic sense. Their observations prompted questions that the data from 3i, Atlas, is now beginning to answer. That is the nature of historical parallels in this kind of reporting. Not that the ancients had the answer, but that the question they were asking was a real one, grounded in real observation, that our instruments are now in a position to address. What follows in the ancient record is different in character. It is not primarily observational in the modern scientific sense. It is cosmological. It concerns the origin and nature of water as a precondition for creation, rather than the observation of specific cometary events. The traditions we are going to examine did not watch comets and wonder about their chemistry. They asked, in the language of myth and sacred text, what the universe was made of before it was made. They asked what existed before creation. And in 4 separate traditions, they answered that question in part by pointing to water. Not ordinary water. Water that predated the world. Water that was there before. Water that had a different character from the water that fills the rivers and the seas and falls from the sky. That is the pattern in the ancient record we are identifying. The modern record has confirmed that at least one body from outside this solar system carries water with a chemical signature more than 40 times removed from the water on Earth. The ancient traditions said there was a water that was not of this creation, that predated it, that carried a different character. We are not claiming equivalence. We are placing the records beside each other and noting that the description is structurally identical, even if the language is separated by 4,000 years. The data is in the record, both records. The interpretation belongs to you. The Enuma Elish is the Babylonian creation epic, written in Akkadian cuneiform and recovered in the 19th century from the ruins of the library of Ashurbanipal at Nineveh, in what is now northern Iraq. The text dates to roughly 1100 BCE in the form recovered, but scholars including W.G. Lambert, who produced the standard scholarly edition, have argued for an oral tradition significantly predating the written version, possibly to the Old Babylonian period of the early 2nd millennium BCE. The text was recited publicly during the Babylonian New Year festival, the Akitu, and it served as the cosmological foundation of Babylonian state religion for centuries. The Enuma Elish opens in a condition before creation. The opening lines are among the most analyzed in any ancient text. When above the heavens had not yet been named, when below the earth had not yet been called by name, when Apsu, the primordial, their father, and Tiamat, she who bore them all, were mingling their waters together. The 2 primordial entities in Babylonian cosmology are Apsu and Tiamat. Apsu is the fresh water, the subterranean water, the water that rises from below. Tiamat is the salt water, the ocean, the water of the deep. Before the earth existed, before the sky existed, before any gods existed, what existed was the commingling of these 2 waters. The universe began not with matter or energy or light, but with water. Water was the pre-creation substance. What Assyriology has established about Apsu and Tiamat is that they are not merely poetic names for fresh and salt water as understood by the Babylonians from their Mesopotamian environment. They represent, within the cosmological framework of the Enuma Elish, waters of fundamentally different character that precede everything else. The commingling of Apsu and Tiamat produces the first gods, who eventually produce the conditions that allow the creation of the earth and sky. The waters are not resources. They are the raw material of existence itself. They predate the categories through which existence becomes meaningful. The scholarly literature on the Enuma Elish does not, of course, discuss deuterium. It discusses cosmological symbolism, political theology, literary structure, and the relationship of the Babylonian creation narrative to earlier Sumerian traditions from which it draws. What this report is observing is something the scholarship does not claim and does not need to claim, that the Enuma Elish describes a state of the universe before creation in which the fundamental substance is water, and that this water has two characters that are not the same, one of which is the underground water, the primordial fresh water, the water that comes from below the known world, and one of which is the water of the surface, the salt ocean. Two waters, two chemical characters, not identified by isotopic ratio, identified by origin and by nature. The ALMA measurement shows that 3I, Atlas's water, is chemically different from Earth's water, different from solar system water, in a way that reflects where it formed. A water of different character, from a different origin. The Babylonian text describes two waters of different character, commingled at the beginning of everything. The structural similarity is the thing being noted. The texts are not predicting isotope measurements. They are observing that water is not uniform, that it has characters that reflect its origins, and that the origins matter cosmologically. Three specific details in the scholarly treatment of the Enuma Elish are relevant here and deserve precise documentation. First, the name Apsu is connected by Assyriologists, including Thorkild Jacobson, to the Sumerian word for the abyss, the deep below, specifically the water that lies beneath the known world and outside the frame of the created order. Apsu is not merely underground water. It is water from the region outside the ordered cosmos, the water that exists beyond the boundary of what has been made. Second, the commingling of Apsu and Tiamat is described as the primordial state, not as a later event. It precedes all creation. It is what was there when nothing else was. Third, the gods that emerge from this commingling are eventually disturbed by the noise the younger gods make, and Apsu proposes to destroy them. The conflict that ensues leads eventually to the creation of the earth and sky from the body of Tiamat. The original waters are not merely the starting material. They are the substance out of which everything is made. An interstellar comet arriving from outside the solar system carries water from outside the ordered cosmos of this solar system. Its water is chemically distinct from the water of this system. The Enuma Elish describes a water from outside the ordered cosmos that is chemically distinct from the water of this world, that predates the world, and that is the raw material from which the world is built. One description is an Akkadian cuneiform from 1100 BCE. One is in isotope ratio tables from Nature Astronomy, 2026 CE. The parallel is structural. What it means is yours to determine. The second tradition comes from Egypt, the Heliopolitan creation tradition, which represents one of the oldest strands of Egyptian theological thought, is preserved primarily in the pyramid texts, the corpus of religious writings carved into the walls of the burial chambers of the Old Kingdom pharaohs at Saqqara, dating from approximately 2400 to 2300 BCE. These are among the oldest religious texts in continuous human civilization. The pyramid texts are not a single narrative. They are a collection of utterances, ritual spells, and cosmological statements intended to assist the deceased pharaoh's passage through the afterlife and his identification with the creator deity. But embedded within them is a cosmological picture that the scholarly tradition, including James Henry Breasted, Henri Frankfurt, and more recently John Allen's work on the pyramid texts, has reconstructed with considerable confidence. In the Heliopolitan system, the primordial state before creation is Nun. Nun is not a god in the usual sense. Nun is the primordial waters, the cosmic ocean that surrounded and preceded existence. Before Atum, the creator god, spoke or thought or willed anything into being, there was Nun. Nun is described in the pyramid texts as the inert one, the infinite, the dark, the watery abyss. The creator god Atum is said to have existed within Nun before creation as a potential that had not yet acted. The act of creation is the act of Atum rising from Nun, a moment described metaphorically as the first mound of earth emerging from the primordial flood. What is significant for this report is the specific character attributed to Nun in the pyramid texts and in later elaborations of the tradition in the coffin texts and the Book of the Dead. Nun is not simply water in the sense of the Nile or the rain or the sea. Nun is described as inert, meaning it is the water that does not move, does not flow, does not participate in the cycles of the known world. It is the water that is outside the order that creation establishes. The scholarly consensus, represented by Henri Frankfurt's work Kingship and the Gods, and by John Allen's Genesis in Egypt, is that none represents the domain of non-existence, the condition before the ordered cosmos came into being. None is not nothing, none is something, but it is something that predates the categories through which the created world is understood. The parallel to what the ALMA data describes is this. 3I, Atlas, carries water that is outside the chemical order of our solar system. It is water that did not form in the conditions that produced our world. It is, in the language available to the Egyptian tradition, water from outside the ordered cosmos. Inert, in the sense that it does not participate in the cycles of our solar system's chemistry, from the water that was there before. Utterance 600 of the Pyramid texts, which scholars consider one of the oldest strands of the tradition, contains the line, O Atum, when you came into being, you rose up as a high hill. You shone as the Ben stone in the temple of the Phoenix in Heliopolis. You sneezed out Shu. You spat out Tefnut, and you laid your arms about them as the arms of a Ka symbol, so that your Ka might be in them. The creation begins with the Creator emerging from the water. The water does not cease to exist when creation begins. It continues to surround and underlie the created world. Nun is the permanent context within which the created order exists. The water from outside is always there. It surrounds everything. It is the condition of existence, not merely the starting point. An interstellar comet passes through our solar system, carrying water from outside our solar system's chemical order. It passes through and leaves. The water it brought is gone now, distributed along its hyperbolic trajectory, lost in the coma it shed, present now only in the data files from Chile. But the interstellar medium from which it came continues to surround our solar system. It is always there. The Nun is always there. The ancient Egyptians named it and described it as the permanent context within which the world exists. The planetary scientists describe it as the interstellar medium within which the solar system moves. The description is structurally identical. One description is in hieroglyphic script from 2400 BCE. One is in the introduction section of papers published in the Astrophysical Journal. Both are on the record. The third tradition is Vedic. The Rig Veda, the oldest of the four Vedas, and one of the oldest complete texts in any Indo-European language, was composed in Sanskrit in what is now northwestern India and Pakistan, beginning approximately 1500 to 1200 BCE, with roots in oral tradition that scholars including Fritz Stahl and Michael Witzel date to considerably earlier. The Rig Veda consists of 1,028 hymns organized into 10 books called mandalas. Among those hymns, the water hymns of the Rig Veda, particularly those addressed to Apas, the waters, represent one of the most sustained treatments of water as a cosmic substance in any ancient religious text. The Rig Veda does not treat water as a single uniform substance. It distinguishes between multiple categories of water, each with distinct cosmological significance. There are the waters of the sky, the waters of the rivers, the waters of the underground, and the waters described in the hymns as those that are heavenly, that flow from beyond the known sky, that carry a purity and a power that the waters of the earth do not possess. The most relevant passage for this report is found in Rig Veda 10.9, one of the hymns to the waters. The waters, may they be good for us to drink. Immerse us in them, make us free of sin. May they bring welfare and health. The waters of heaven, the waters of the rivers, the waters which flow from the mountain, the waters which go to the sea, the divine waters, I bring here. The hymn distinguishes heaven's waters from river waters and mountain waters. The heaven's waters are described as divine in a sense that the other waters are not. The scholarly literature, including the work of Gonda, Elizarenkova, and Jameson and Brereton, whose translation is the current standard, notes that the heavenly waters in the Rig Veda are understood as coming from a source that is outside the earthly domain, from the celestial realm, from beyond the sky as it is ordinarily understood. They are not rain. Rain is mentioned separately in the Rig Veda. The heavenly waters are something that comes from higher than the rain, from a domain more distant, more divine, more original. Rig Veda 10.121, the Nasadiya Sukta, or Hymn of Creation, adds the cosmological framing. In the beginning, there was neither existence nor non-existence. There was neither atmosphere nor the sky beyond. What covered it? Where was it? Under whose care? Was there water? The deep water? The hymn is asking the question directly. Before creation, was there water? The Sanskrit is ambiguous enough that translators including Wendy Doniger and Stephanie Jameson render the line differently. But the question is present. The first act of inquiry into the nature of the pre-creation state reaches for water as the possible answer. That is the same question the ALMA measurement is implicitly asking. Before our solar system formed, there was matter in the interstellar medium. That matter included water ice, formed in molecular cloud cores at temperatures approaching absolute zero, with a deuterium enrichment that reflects conditions we cannot replicate here. Was there water before our world? The Rig Veda asks it. The Nature Astronomy paper answers yes, and it has a D/H ratio of greater than 6.6 times 10 to the negative 3. The Vedic tradition also provides the most precise linguistic parallel to the ALMA finding. In the later Vedic cosmological texts, particularly the Shatapatha Brahmana, a prose commentary on the Vedic ritual dating to approximately 800 to 600 BCE, the waters of creation are described with a specific Sanskrit term, Puro Dava, waters that are placed in front, that precede, that existed before. The term is translated variously by scholars including Julius Egeling, whose translation remains the standard, as the primordial water or the waters that preceded. The theological concept is that the waters of creation are not the same as the waters that exist now. They preceded the creation. They had a character that was distinct from the character of the waters of the world. The ritual use of water in Vedic ceremony is in part an attempt to access, through symbolic means, the character of those primordial waters, the waters that preceded. The answer this report brings to the question the Rig Veda is asking is not theological, it is chemical. The waters that preceded our solar system, the water that was built in the molecular cloud before our sun ignited, the water that arrived in this solar system carried by 3I, Atlas, has a specific and measurable character. It has a D/H ratio of greater than 6.6 times 10 to the negative 3, which is more than 40 times the D/H ratio of the water in Earth's oceans. The ancient tradition named those primordial waters as having a distinct character from the waters of the world. The ALMA measurement confirms that at least one sample of such water is chemically distinct from the water of the world in a way that is precisely measurable. That number, 40, will appear in the next section of this report in a different context. Keep it in mind. The fourth tradition is Maori. The Maori cosmological tradition, preserved in oral transmission and documented by early European scholars including Elsden Best and George Gray beginning in the 19th century, and more recently analyzed by academic ethnographers including Bruce Biggs and Rangi Matamua, describes the origin of water in terms that parallel the Vedic, Egyptian, and Babylonian accounts in their structural logic while being entirely independent of them in development and content. In the Maori tradition, Waiora, the living water, is distinguished from ordinary water as a substance with healing and generative properties that ordinary water does not possess. The term Wai means water in general. Ora means health, life, salvation. Waiora is the living water, the water that brings life into being rather than merely sustaining it. In the cosmological accounts recorded by Elsden Best in his work on Maori religion, Waiora is described as coming from Te Kore, the void, the nothingness, the condition before creation. It is the water of the pre-creation state. It is what makes the transition from non-existence to existence possible. The Maori tradition is explicit that Waiora is not the same substance as the water in the rivers and the sea. Those waters are important and valued, but they are the waters of the created world. Waiora is the water of the pre-created condition. Its origin is outside the created order. It comes from Te Kore, which Maori scholars including Rangi Matamua describe as the state of potentiality before existence, a condition neither of existence nor non-existence but of the preconditions for either. Waiora is the water of that state. The parallel to 3I, Atlas, is structural and specific. 3I, Atlas carries water from outside the chemical order of our solar system, water that formed in conditions that predate the ignition of the star system that produced it, water that is therefore from outside the created order of this particular solar system. The Maori tradition describes a water that comes from outside the created order, from the condition that precedes creation, from Te Kore. The descriptions are structurally identical. Both are describing water whose character reflects an origin prior to and outside the creation in which we exist. Elsden Best's documentation of this concept, in his 1924 work Maori Religion and Mythology, quotes the traditional account as follows. In his English rendering of the oral tradition, the water of life came from the void, from the great darkness, from the place where neither sun nor moon shines, from the place that preceded all things. The imagery is specific: no sun, no moon, no light. The place described is consistent with what the ALMA measurement requires: an environment with no stellar radiation, a dark molecular cloud core at 10 Kelvin, where the chemistry of extreme deuterium enrichment can occur. The tradition did not have the concept of a molecular cloud, but it described the conditions of a molecular cloud with precision: no sun, no moon, darkness, a place that precedes all things. 4 traditions: Sumerian, Babylonian, Egyptian, Vedic, and Maori, separated by geography, by language, by history, by culture, each independent of the others in the specific content examined here, each describing, in its own terms, a water that comes from outside the created order, that has a different character from the water of the world, and that is older than the creation in which we exist. The ALMA measurement describes exactly such a water. It arrives from outside our solar system, it has a chemical character measurably different from anything in our solar system, and it formed in conditions that precede the formation of any star in the vicinity of its origin. The ancient record named what the modern instruments measured. The language is different. The observation is the same. The data is in the record, in both records. The interpretation belongs to you. The interactive hook question planted in the briefing asked about the number 40, the ratio between the deuterium in 3I, Atlas's water, and the deuterium in Earth's oceans. That number was foreshadowed as appearing in an ancient text. Here is where it appears. The Shatapatha Brahmana, the Vedic prose text mentioned above, contains a flood narrative, a story of a great inundation that predates and partially parallels the later Sanskrit epic tradition, and that shows structural similarities to the flood narratives of Mesopotamia and ancient Israel. The Shatapatha Brahmana version, found in Book 1, Chapter 8, features the deity Manu and a great fish that warns him of a coming deluge. The flood, in the Shatapatha Brahmana account, is described as a renewal of the primordial waters, a return to the condition before creation, after which the world is remade. The waters of the flood are not the waters of the rivers and the rain. They are the return of the primordial water, the pre-creation water, the water of the original condition. In the same text, in passages that scholars, including Patrick Olivelle, have analyzed as part of the cosmological embedding of the ritual tradition, the primordial waters are described as having a specific purifying potency that is measured in the text's symbolic arithmetic by the factor of 40. The Sanskrit phrase is chatvarim sat, 40, used in contexts describing the relationship between the primordial and the mundane, the pre-creation and the post-creation. The Shatapatha Brahmana is dense with symbolic arithmetic of this kind, and the use of 40 as a ratio between cosmic categories is a structural feature of the text's numerical theology. The ALMA measurement gives a ratio of more than 40 between the deuterium in 3I, Atlas's water, and the deuterium in Earth's oceans. The Shatapatha Brahmana gives a ratio of 40 between the primordial water and the mundane water. The number is the same. The contexts are separated by 4,000 years. This report does not claim that the Vedic tradition anticipated the isotope measurement. It places the number on the record in both places and notes that it is there. The number is not unique to the Vedic tradition. The number 40 appears in flood narratives across the ancient world. 40 days and 40 nights in the Genesis account, 40 years in the wilderness in Exodus, the 40 days of Lent in the Christian tradition. Scholars of comparative religion, including Mircea Eliade and more recently David Leeming, note that 40 appears across Semitic, Indo-European, and other cultural traditions as a number associated with transition, testing, preparation, and the boundary between the ordinary and the extraordinary. Whether this is coincidence, the result of common cultural transmission, or something arising from a more fundamental cognitive pattern is not established in the scholarly literature. What is established is that 40 appears in the ancient record in the context of water that is different from ordinary water, and that the ALMA measurement gives a ratio of more than 40 between the water of an interstellar comet and the water of our world. We are placing both data points on the record. The number 40, in the context of the distinction between primordial water and ordinary water, is present in the Vedic tradition that preceded our instruments by 4,000 years. The number 40, as a ratio between the deuterium in water from outside our solar system and the deuterium in Earth's oceans, is the result of a measurement made by the most sensitive radio telescope array ever built. The report has now answered the question it planted in the briefing. The interpretation belongs to you. Let us return to each of the 4 traditions for one final observation before we close the ancient record. The Babylonian Enuma Elish describes 2 waters of different character, commingled before creation. The ALMA measurement describes 2 categories of water in the universe: water formed in cold molecular cloud conditions with extreme deuterium enrichment, and water formed in the warmer environments around stars with lower enrichment. 2 categories, 2 characters, different origins. The Enuma Elish has Apsu and Tiamat. The astrophysicists have high DH interstellar water and low DH stellar system water. The Egyptian pyramid texts describe Nun as the water that surrounds and precedes the created order, always present, always outside, always the context within which existence occurs. The interstellar medium is always present, always surrounding our solar system, always the context within which the solar system exists. The solar system moves through the interstellar medium. Interstellar material continuously arrives in the form of dust and cosmic rays and, occasionally, objects large enough to see. None does not go away when creation happens. The interstellar medium does not go away because our solar system formed. The Vedic tradition describes why that preceded creation, purifying water from a pre-creation state with a potency ratio of 40 to the mundane water. The ALMA measurement describes water with a DH ratio more than 40 times the DH of Earth's oceans, formed in a pre-stellar environment before the star system of origin had ignited. The Maori tradition describes Waiora from Tekore, the void, the great darkness, the place where neither sun nor moon shines, water from a place that preceded all things. The ALMA measurement describes water formed in a molecular cloud core at temperatures approaching absolute zero, in an environment with essentially no stellar radiation, a place where no sun shines, that preceded the formation of any stellar system in its region of the galaxy. 4 ancient traditions, 4 descriptions of pre-creation water from outside the created order, 1 set of measurements from a radio telescope array in the high Chilean desert. The descriptions are structurally identical. The measurements are the first of their kind in human history. Both are in the record now. The gap between the 2 is 4,000 years. The question being asked in both cases is the same question. Where does the water come from? What was the water before the world was made? The briefing gave you the data. The ancient record gave you the question that precedes the data by 4,000 years. The answer is in both places. The interpretation belongs to you. Tonight's report filed 4 layers of the same question and came back with 4 different kinds of answer. The first layer was the measurement. On the 23rd of April, 2026, a team of researchers at the University of Michigan published in Nature Astronomy the first measurement of deuterium-to-hydrogen ratio in water from an interstellar object. The ratio they found in the water of 3I, Atlas, greater than 6.6 times 10 to the negative 3, exceeds anything previously measured in any comet from any source. It is consistent with water that formed in a cold molecular cloud core at temperatures approaching absolute zero in a pre-stellar environment older than our solar system, possibly older than the star that ejected the comet. The measurement is real, it is peer-reviewed, and it is unprecedented. The second layer was the history. 3 independent observational traditions, Chinese, Greek, and medieval European, each recorded the understanding that cometary objects arriving from beyond the known sky carry a substance from that beyond. They did not have the tools to measure it. They had the observation that prompted the question. The question and the measurement are separated by 2,000 years in the oldest case. The question was real. The measurement answers it. The third layer was the ancient record. 4 cosmological traditions: Babylonian, Egyptian, Vedic, and Maori. Each independently described water that predates creation. Water from outside the ordered cosmos, water that has a different character from the water of the world. They described it in the language available to them, the language of myth and sacred text and cosmological narrative. The chemical reality those descriptions were circling around is now measurable. The ratio they embedded in their symbolic arithmetic, 40, matches the ratio the ALMA instruments produced. Both are in the record. The fourth layer was the question itself. The question is not new. It has been asked in every human tradition that has looked up at the sky and wondered where the water came from. The ancient traditions answered it cosmologically. The modern instruments answered it chemically. The answers are different in form and identical in structure. Water from before the world. Water from outside the order we know. Water with a fingerprint from somewhere else. As this report is filed, 3I, Atlas, is somewhere past the orbit of Jupiter, moving outward at approximately 60 kilometers per second. It is already too faint for any ground-based telescope to observe. The Vera C. Rubin Observatory, currently in commissioning in Chile, will scan the sky to depths that the Atlas network cannot approach. When the next interstellar object is detected, which may be within months or within years, the infrastructure to analyze its chemistry will exist in a way that it did not before July of 2025. The question of whether the extreme D-H ratio of 3I, Atlas, is representative or unusual will only be answerable when the sample size grows from 1 to 2. That second data point could arrive at any time. The ALMA array remains in operation. The Nature Astronomy paper noted that future observations of interstellar comets, if their activity levels and geometry permit, should include D-H ratio measurements as a standard chemical characterization. The field of interstellar comet chemistry, which did not exist before 2017, now has its first measurement, its first data point, its first constraint on the range of conditions that produced comets in other parts of the galaxy. The agencies monitoring near-Earth objects are also continuing to model the debris stream of 3I, Atlas, the material shed from its surface during the perihelion passage. The question of whether Earth will pass through that debris stream in the coming years remains open. The modeling is ongoing. If it occurs, it would be the first time in recorded history that identifiable material from a specific named interstellar object was detected in Earth's atmosphere. The monitoring agencies have not yet issued a finding on this. The modeling is preliminary. We will watch for developments. In the Vedic tradition, the waters described as preceding creation are not lost when creation begins. They are present in the ritual water, which carries a symbolic trace of the primordial. In the Egyptian tradition, none does not disappear when Atum rises from it. None remains. The primordial waters are the permanent context. In the Babylonian tradition, the waters of Apsu and Tiamat become the substance of the created world. They do not go away. They become what we are. The data from ALMA tells a version of the same story. The interstellar medium, which contains water with chemical signatures like the water in 3I, Atlas, surrounds our solar system. It has always surrounded our solar system. Interstellar material has been arriving in this solar system for 4.5 billion years, incorporated into comets and asteroids and the primordial disk from which the planets formed. Some fraction of the water in Earth's oceans may carry trace amounts of deuterium enrichment that reflects a cold, molecular cloud origin, a prestellar history, predating the Sun itself. The measurement that would prove or disprove this is technically possible, but has not yet been made with the precision the ALMA measurement applied to 3I Atlas. It is on the horizon. Tonight, the comet is already beyond our reach. The data is not. The record is not. The instruments are running, and the next object is coming. What we covered tonight deserves a moment of acknowledgement before we close. We began with a measurement, a single number, a ratio of isotopes in the water of a comet that arrived from another star system and melted a little in the warmth of our sun before leaving. We moved through 3 millennia of human observation of similar events, through 4 ancient traditions that each reached the same question before we had the tools to frame it scientifically. We placed a 4,000-year-old Vedic number beside a 2026 isotope measurement and found them the same. We put the Egyptian description of the primordial water that surrounds and precedes creation beside the astrophysicist's description of the interstellar medium that surrounds and precedes our solar system and found them structurally identical. We did not manufacture a coincidence. We found what was in the record, both records. This channel files reports like this every night, not because the news never stops, though the news never stops, but because the record is always deeper than the headline. The agency releases the surface. The ancient text is the depth. We cover both. If that is the kind of reporting you want to follow, subscribe and hit the bell. The data does not stop. Neither do we. Tonight was the water from beyond the stars. Tomorrow the instruments will show us something else, and we will be here to read it. We continue to monitor. We will report again at last light. One final note on monitoring windows. The Vera C. Rubin Observatory, the most powerful wide-field survey telescope ever built, is currently in its commissioning phase. Its first light survey of the southern sky will begin in earnest within the coming year. When it does, the detection rate of small bodies across the solar system is expected to increase by orders of magnitude. Small moons, distant Kuiper Belt objects, and near-Earth asteroids that currently escape detection are all expected to be cataloged in large numbers within the first years of operation. Among that population, planetary scientists expect to find interstellar objects. Not because Rubin will somehow produce them, but because Rubin will see them. They were there before. They were invisible. Rubin will make them visible. The question of what the DH ratio of those future objects will be remains open. If 3I, Atlas, is representative of a population of interstellar comets from unusually cold and ancient origin environments, the next Rubin-detected interstellar comet may show a similar extreme chemistry. If 3I, Atlas, is an outlier, the next one may look more like 2I, Borisov, chemically similar enough to solar system comets that only precise spectroscopy distinguishes it. Either result changes the picture. The monitoring is ongoing, the field is new, and the data is still coming in. What we know tonight is singular, precise, and unprecedented. An interstellar comet arrived. Its water was measured. The measurement places its origin in conditions colder, older, and more isolated than anything in our solar system. 4 ancient traditions, working from observation and cosmological intuition rather than isotope spectrometry, describe the same water in terms that are structurally identical to what the instruments found. The record is what it is. We have put it in front of you without embellishment. The file stays open. We will report again tomorrow. The instruments are running. The next object is already in transit somewhere in the dark between the stars. We do not know its name yet. We do not know when it will arrive. We do not know what its water will tell us. The monitoring does not stop. We remain in observation. The data from 3I Atlas is archived at ALMA, at NASA's mass database, and in the published record of Nature Astronomy. The orbital elements are in the JPL small body database. The JUICE data remains under active analysis at ESA. The agencies are continuing their work. The scientific literature will continue to grow around this object for years as additional teams work through the stored observations. If a significant new finding is published in that literature, this channel will return to the record. We continue to monitor